Welcome to today's session where we are solving a 2017 paper 2 question 9b. The question reads, find the coordinates of the points on the curve y is equal to 2x to the power 3 minus 3x to the power 2 minus 6x minus 36x, minus 3, where the gradient is 0. So there are key terms in this question, and the most key term is where the gradient is 0. So we have to know where the gradient is 0. What do they mean? In every curve, if we were to sketch this graph, there will be parts where it will look like this. These are the parts where actually the gradient is 0. It's at these points. So where the gradient is 0, we say dy over dx is actually 0. It is actually at the stationary. If they don't want to say where the gradient is 0, they will say find the coordinates of the stationary point. They mean the same thing. When they say find the coordinates of the stationary point, or when they say find the gradient, find the coordinates of the gradient where the gradient is 0. So in this case, the dy dx is 0. So how do we solve this question? We first begin by differentiating the equation given. We have been given this equation. So you begin by differentiating this. You say dy over dx. We all know the rule of differentiation. The power reduces by 1. When you multiply the power with the coefficient of x, the power reduces by 1. So it's 3 times 2, which is 6. 6x, the power reduces by 1, so it will be to the power 2, minus 2 times 3, which is 6x. The power reduces by 1, so it will just be like that. Then minus this x has power 1 here. We were told previously to say if a number has power 1, we usually don't like that power there. But you have to know to say there is power 1 there. So 1 multiplied by 36, it will give us 36. It will actually give us 36. Then here we don't differentiate the number if it doesn't have x, so it tends to be 0. So we don't actually differentiate it, so it will be 0. So in that case, we actually don't write it. Then after we differentiate, this is now where we say 6x to the power 2 minus 6x minus 36 equate to 0. Where the dy dx is what? 0. Or where the gradient is 0, so you equate it to 0. From there, you divide by 6 to reduce the numbers. So we're going to have x to the power 2 minus x minus 6 into 36, that's 6, equate to 0. So if you look at it, actually, it has turned into a quadratic equation. And when you look at it and analyze it, it's somehow a question that can be solved using factorization method. So we go by factorization method. We know the rule of factorization method, where we look for the product, sum, and the factors. The product is when we multiply this A multiplied by C, this one becomes the B. When you multiply A times C, the values of A and C, you get the product. So we say 1 times negative 6, we have negative 6. Then the sum, we get the value of B, which is the negative 1 there. The factors are the two numbers. When you multiply them, you get negative 6. When you add them, you get negative 1. We are looking for negative 3 and 2. Then we fuse them here by getting the value that is actually on the sum. We fuse the two factors. So it will be x squared minus 3x plus 2x minus 6 equates to 0. From there, we split them into 2, where we say what is common here is actually x. We will remain with x minus, we get the other x there as what is common. Remain with 3. From there, we have 2 to be common. Then we remain with x minus 2 into 6, that's 3. When you are factorizing a quadratic equation, one principle that you should take note of is that these two, they should be same, so that we just pick one and leave the other one. When we pick this, we also pick what was left out. We equate them to 0. From there, we can now say x minus 3 and x plus 2 equate to 0. So we say x minus 3 is equal to 0, or x plus 2 is equal to 0. So we have x is equal to 3, or x is equal to negative 2. So these were the pairs of the x's in the pairs of coordinates. So, which is, I mean this. They want us to find the pairs. They want us to find what? The coordinates. So, we now have 3 with the one we are going to find, and we have negative 2 with what we are going to find to the other end. How do we find now the coordinates of y? This is why you go back to the original equation. You go back to the original equation. When you go back to the original equation, you start fusing in the value of, we start fusing 3 on every value of x. So it will be y equals 2, 3, then we have this. Sorry, this is a 3. Good. So from there, we'll work out something. We'll say 2 by 27 minus 3 by 9 minus 36 minus 3. So we can punch that one on the calculator, because this is maths paper 2, meaning you can use a calculator. So we say 2 times 27, which is giving us actually 54. 54 minus 27 minus 36 minus 3. So we have 50. We say 54 minus 27 minus 36 minus 3 equals, we have negative 12 there. We have negative 12. So we say negative 12, y is equal to negative 12. We can punch again to check if we are correct with what we are doing there. Sorry. It's supposed to be actually minus 108 minus 3. It's actually 108 minus 3. From there, we say 54 minus 27 minus 108 minus 3. We have negative 84. Negative 84. So we fuse in negative 84 there. That's another pair of coordinate. Then we also fuse in the negative 2 there to find the other value. We say 2, sorry for the marker. We say 2, there is negative 2 to the power 3 minus 3, negative 2 to the power 2 minus 36, negative 2 minus 3. So we have 2 by actually negative 8, then we have minus 3 by 4, then we have 2 there, 72. It will actually be a positive now, 72 minus 3. So from there we have negative 16 minus 12 plus 72 minus 3. Negative 16 minus 12 plus 72 minus 3. This is giving us 41. Y is equal to 41. So here is it, comma 41. So these are the coordinates. We write them, say 3, comma negative 84 and negative 2, comma 41. Coordinates of the turning point or where the gradient is 0. Thank you very much. We end here.